All particles are made of two protons. I mean, alpha particles are made of two protons and two neutrons. Now, pag ito yung, if you have two protons and two neutrons, if you're going to add it up, that is already the atomic mass, di ba? Di ba, atomic mass is equal to the number of protons times plus the number of neutrons. So, in this case, it means that they have a charge of plus 2 and a mass of 4. Okay? So, ang mass ng alpha is 4. Ang kanyang charge or atomic number is 2. That's why the charge is plus 2. Now, the atomic mass is measured in atomic mass units, where each proton and neutron is equal to 1. Ibig sabihin, ang isang proton, 1 ang atomic mass niya. Ganun din si neutron. Now, we can write the alpha particle emitted we can write it as 2 alpha 4. 2 alpha 4. During reaction, itong isusulat ninyo. Or, because they are the same as helium nucleus. Tignan nyo si helium sa periodic table niya. Look at helium. It has an atomic number of 2 and atomic mass of 4. So, it is similar to alpha. So, pag nagbabalance kayo ng nuclear reaction, pag alpha emitter yung nucleus or yung element, ganito yung isusulat nyo. It can be 2 alpha 4 or 2 helium 4. Okay, it can be 2 alpha 4 or 2 helium 4. Alright? So alpha particles are relatively small and heavy. They have a low penetrating power. Pag nag-emit ng alpha particle, the tendency for it is to emit alpha particles, of course. So thus, we can say that alpha particle is actually light, slow and heavy, I should say. They have a low penetrating power. You can stop the penetration of alpha particle by shielding it with a sheet of paper. Pwede mong stop. Okay, pwede mong stop making use of paper para hindi na siya makapenetrate. Now, because they have a large charge, bakit ko sinabing large charge? Because the charge is positive 2, no? So when the charge is positive 2, somehow, it has the capacity to attract or pull electrons towards it from other atoms. They have a large charge, alpha particles ionize. That means to say they pull electrons from other atoms strongly. Take note, because of the positive 2 charge. Okay, how about beta? Now, si beta naman, beta particles have a charge of -1, negative 1 siya. And the mass is about 1 over 2,000 of a proton. So this means that beta particles are the same as an electron. Diba, ang electron is somewhat has a very, very low atomic mass compared to proton. So it is almost negligible. It is almost negligible. So this means that beta particles are the same as an electron. So we can write or we can represent beta particles being emitted by an element or by the nucleus of an element by writing beta -1. Or because they're the same as an electron, remember an electron is also -1. Now we can write now in isotope notation as -1 beta 0. Take note, pag beta particle -1 beta 0. 0 is the atomic mass of a beta particle, -1 is the charge. Ito siya, oh. -1 is the charge. Alright? Naintindihan niyo? Yung alpha, 2 alpha 4 or 2 helium 4. Si beta, -1 beta 0. Kasi wala siyang atomic mass. Pero may charge siya, -1. just like electron. Now, these beta particles are fast and light. Beta particles have a medium penetrating power. They are stopped by a sheet of aluminum or plastics, or you can also make use a sheet of copper metal. Pwede mo siyang i-shield. So it's easier to shield alpha than beta. Kasi gagamit ka na dito ng metal or plastics. Compared to alpha, papel lang pwede na. Beta particles also ionize atoms that they pass, but not as strongly as alpha particles do. Hindi as strong as alpha particles. Okay? Can you differentiate now alpha from beta particle? Can you differentiate now? Mr. Villapando?
Yes po, ma'am.
Okay. So how do you differentiate beta from alpha? Huh? How do you differentiate beta from alpha? Mr. Villapando,
Ma'am, ano po ulit yan, ma'am?
how do you differentiate now beta from alpha particle?
Ma'am, yung ano, ma'am, yung beta particles po, ma'am, meron po siyang charge na charge na negative 1, or minus 1, ma'am.
And then,
Yung beta particles naman po, ma'am, ano, ma'am?
alpha ka mo ah.
Ay, alpha?
Hmm.
Ma'am, hindi ko po matandaan yung sa alpha, ma'am, eh.
Ako,
Sa
inulit-ulit.
beta and...
Inulit-ulit ko pa yung alpha kanina, di ba? Ha? Oh, Mr. Marquez.
Ano ma'am? Yung alpha particle ma'am, yung pinakamalaking particle, tapos siya yung may pinaka-least na ano, na penetrative power ma'am. Tama
Then,
po ba?
how do you denote it? Paano ang notation niya?
Ng alpha particle ma'am.
Hmm.
Wait lang, ano mo? Saan nga ba? Wait lang po. Limutan ko eh.
Mag-take down na kasi kayo ng notes pag nagle-lecture tayo. Always remember that for an alpha particle, the notation is 2 alpha 4. 2 alpha 4 or 2 helium 4. Gagamitin natin yun pag nag-balance na tayo ng nuclear equation. Okay? So again, beta particles ionize atoms that they pass, but not as strongly as alpha particles do. Now, take note, beta particle is the same as an electron. They have a negative charge. Then let's go now to gamma waves. Gamma rays are waves. They are not particles. Take note, gamma rays are waves. They are not particles. This means that they have no mass and no charge. So we sometimes write 0, gamma, 0. Okay, gamma, 0, gamma, 0. Now, sa balancing of nuclear equation, pag nag-emit ng alpha particle and nag-emit din ng gamma ray, if we are going to include or indicate that there is a corresponding gamma ray that was emitted, it can be indicated by +2, 0, gamma, 0. Meaning, it doesn't do anything with the reaction. Hindi siya ibabalance kasi it has no atomic mass, it has no atomic number. Okay, so ganito ang pagsulat. Gamma rays have a high penetrating power. It takes a thick sheet of metal such as lead or concrete to reduce them significantly. Diba, yung mga shelters ng those countries who are having wars at present, mayroon silang mga shelters to protect them from any radioactive fallout just in case yung opponent nila ay gumamit ng nuclear weapon. Okay? Gamma rays do not react or do not directly ionize other atoms, although they may cause atoms to emit other particles, which will then cause ionization. We don't find pure gamma sources. Gamma rays are emitted alongside alpha or beta particles. Strictly speaking, gamma emission isn't radioactive decay because it doesn't change the state of the nucleus. It just carries away some energy. Kasi nga, it has nothing to do with the reaction. Pero kasama siya pag nagkaroon ng decay kasi nga, it is in the form of energy. Ang dala-dala niya, energy during decay. Okay? So, let us summarize. Alpha can be denoted by 2 alpha 4 or 2 helium 4. Beta, negative 1 electron 0 or negative 1 beta 0. Gamma is 0 gamma 0. Right? Again, gamma ray, it is not a particle. It's just a burst of energy. It carries away energy. Okay. So we have now what we call the nuclear decay reactions. Some elements are naturally unstable. They tend to undergo alpha decay or beta decay to become more stable. They may take several steps in order to achieve this. Thus, we observe decay chains, also known as series decay. Meaning to say, pag nag-decay siya, nagkaroon ng alpha decay, okay, so nag-transform siya into another element. Now, if this element is still unstable, it will undergo another decay. Kaya nga dito sabi, a series of decay until such time na maging stable na siya. For example, it takes uranium-238. As you can see, uranium is a radioactive element under the actinide series, yung uranium-238. There are 14 steps of alpha and beta decay to become completely stable. Could you imagine that? 14 steps. Now, you will learn how to compute the half-life, the series of half-life, and also how much remain after a certain half-life later on. Okay? Mag-compute tayo mamaya. Okay. When you say nuclear reactions, class, they are reactions that affect the nucleus of the atom. Meaning to say, nag-change yung neutron sa loob. Either it is converted into proton or yung proton na convert as neutron. Alright? So, there is what we call an instability inside the nucleus. Okay, instability. Kaya, what makes it unstable? Pwedeng madagdagan, pwedeng mabawasan yung number of neutrons. So, pag nabawasan yung number of neutrons, meaning to say, bumababa yung atomic mass. Since atomic mass is equal to number of protons plus number of neutrons. Okay, this is the symbol for radiation. So if you see a sign like this, a signage like this, in a particular area, that means to say you have to move away or ang tawag dito, make a distance away from the particular area. Now, radioactivity is the phenomenon of radiation. Particles such as beta or alpha and energy in the form of gamma are being ejected spontaneously by an unstable nucleus until it reaches a more stable arrangement. Okay? Yun yung tinatawag nilang radioactive decay. Okay, so this is just a representation of how an unstable nuclei or nucleus will become stable. So unstable siya. And then the process of attaining stability, you call it radioactive or metastable until such time that it reaches its stability form or stable form. Now, when you say nuclear stability, it is determined by the ratio of protons to neutrons in the nucleus. Depende kung ilan yung number of proton or number of protons niya sa nucleus. So if there are conditions that we're going to follow here, para ano ang basihan natin, para siya ay maging unstable. So there should be a number of protons and neutrons to be maintained in order to reach stability. Now, let's take first the composition and structure of the nucleus. Of course, um, neutrons and protons, which are found in the nucleus, we consider them, or we can call them as the nucleons. Now, of course, how do these nucleons or the protons and the neutrons stay in the nucleus? There is what you call a strong nuclear force, the force that holds the nucleons together. Okay, yun yung nag-hold sa center, the strong nuclear force. Now, what are the characteristics of a nuclear reaction? Isotopes of one element are changed into isotopes of another element. So, ano na ba yung isotope? Ano na yung isotope? Isotopes are elements with the same, what you call, structure but different number of neutrons. Nag-iiba yung number of neutrons niya. That's why we call it isotopes. Contents of the nucleus change. Okay, the contents of the nucleus change. It can be the neutrons will be transformed or will be converted into protons or vice versa. And also large amounts of energy are released during a nuclear reaction. So again, let's define again what is radioactive decay. It is the process by which the unstable nuclei lose mass or energy by emitting radiation. Bago siya maging stable, mag-iinit muna siya ng radiation. Eventually, unstable nuclei achieve a more stable state when they are transformed to atoms of different element. So, ang nangyayari nito, in order to attain a stable nuclei, yung radioisotope or yung element mismo is transformed into another element. Nag-iiba siya. Okay, so you will see some examples of this later on. Okay, ano yung sinasabi nating stable nuclei? As you can see from the graph, that is protons versus neutrons. As you can see from the graph, this is a balance of proton equals neutrons. Pareho, 45 degrees. Nasa gitna. Now, this graph shows the stable nuclei in red. So, ito dapat yung stable nuclei. But there are several things to notice in here. So, dapat hindi ka dito sa middle at 45 degrees. Dapat you will go higher to reach a certain point for it to become stable. Okay, so ito na yung sinasabi ko kanina. There are no stable nuclei with an atomic number of higher than 83. Okay? Pag tumaas ng 83 yung atomic number or the neutron number higher than 126, it is already unstable. Okay? So, tignan nyo itong graph. 83 dito, di ba? 83 and 126 nag-meet dito sa point na to. So, during radioactive decay, meaning to say that this line should be reached until to this point, para maging stable si nuclei. Take note, 83 and 126. 83 for the protons, 126 for the neutrons to become stable. It should be lower than 83 or lower than 126. So higher than 83 and 126 kasi ito yung pinakaano natin, control to attain stability. Okay, the more protons in the nuclei, the more neutrons are needed for stability. Notice how the stability band pulls away from the protons equals neutron line. P is equal to N. Okay? So, if there are more protons dito, dapat maitulak pataas itong line para ma-reach niya itong point na to. So, what specific decay should happen para matulak or makontrol yung stable nuclei? Remember, 83 and 126 ang natin basis. And stability is favored by even numbers of protons and even numbers of neutrons. and there are 168 of the nuclei, stable nuclei, are even, while only 4 of the stable nuclei are odd. Take note, it should be even, meaning to say even number yung protons, even number din yung neutrons. Para stability is favored. Okay? Now, the types of radioactive decay. So, when an unstable nuclei decay, the reactions generally involve the emission of a particle, either it is an alpha or beta, and or energy in the form of gamma. For each type of decay, the equation is balanced with regard to atomic number and atomic mass. In other words, the total atomic number before and after the reaction are equal, and the total atomic mass before and after the reaction are also equal. Ngayon, class, it's a different story with the balancing that we had before sa chemical reactions. Sa chemical reactions, ang binabalance natin coefficients. The number appearing before the formula or before the symbol. Pero dito sa nuclear chemistry, balancing nuclear equation, we will be doing is to balance the atomic mass and the atomic number. We are also going to balance the neutrons and the protons. Okay? Hindi coefficients. We will not be dealing with coefficients here. Okay, so may example na tayo dito. Get your periodic table. When particles break down in the nucleus in an atom of an element, that is what you call radioactive decay, the element changes into another element. This is called transmutation or transformation. Okay. Now, look at your periodic table. What element is symbolized by Pu, capital P, and then small letter U? What element is it? Look at your periodic table. How do you call it? Mr. Rhinon? Mr. Rhinon?
Ma'am?
What element is denoted by the symbol capital P and small letter U sa periodic table? Ha?
Plutonium po.
Okay, plutonium, di ba? So, plutonium 94239. Tingnan nyo si plutonium, yung atomic mass niya, naka-enclose sa parenthesis. Napansin nyo? Napansin nyo? Nakita nyo ba yun? Naka-enclose sa parenthesis yung atomic mass ng plutonium. Can you see it?
Yes po, ma'am.
Okay. It means to say that the unstable siya. Meaning to say, nag-iiba yung atomic mass. Kasi pwedeng ma-convert si proton as neutron. Depende kung anong emitter siya. Okay? Kaya naka-enclose sa parenthesis. Now, plutonium undergoes alpha decay. Plutonium is an alpha emitter. Ibig sabihin, nag-i-emit siya ng alpha particle. So when plutonium 94239 undergoes alpha decay, it changes or it transforms into uranium 92235. Okay? Uranium 92235. Itong nasa baba, atomic number or charge. Yung nasa taas, atomic mass. So if it undergoes alpha decay, mag-i-emit si plutonium ng alpha to alpha 4 or to helium 4. 'Di ba alpha emission ito? Tama ba tayo? To alpha 4 or to helium 4. 'Di ba, Mr. Doringo?
Ma'am, excuse lang po sarili ko, ma'am. Kahatid lang po ako ng kapatid ko.
Hindi mo na maabutan yung highlight of nuclear chemistry.
Titignan ko lang po sa ma'am, sa bright space po.
Okay, so as you can see here, we will be balancing the equation. Diba? Nakita nyo? 235 plus 4 is 239. Ayan, 239. 92 plus 2 is 94. Naintindihan nyo? Ito, ganito lang ang pagbabalance ng nuclear reaction. Okay, did you get it?
Yes po, ma'am.
Now, sa beta decay naman, we have here carbon 14. 6 carbon 14 is a beta emitter. Nag-emit siya ng beta particles. You might be wondering that carbon has an atomic mass of 12, di ba? But actually, there is an existing carbon 14 na nagdi-decay to attain stability. Ngayon, pag nag-decay siya, it will be transformed into nitrogen 714, di ba? Na-transform siya into another element. But, nag-emit siya ng beta particle, negative 1, electron 0, or negative 1, beta 0. So, if you're going to balance, 7 minus 1 is equal to 6, 14 plus 0 is equal to 14. Nakuha nyo, the difference between alpha and beta decay? Naintindihan? Okay. So sa gamma decay naman, 'di ba walang mass, walang atomic number si gamma. Therefore, if you are going to what is element TC sa periodic table nyo, how do you call it? How do you call it? Element number 43. It is also a radioactive element. Look at your periodic table. What is it? What element is it? How do you call it? Mr. Dupa.
Technetium po, ma'am.
Okay, technetium. Technetium. So when technetium 4399M, so ibig sabihin ng 99M, that means to say that it will be transformed to another element. But since it undergoes gamma decay only, no transformation will happen. Kasi nga, when it emits gamma ray, nothing happened to the nucleus. That's why we can say that gamma ray actually goes along with beta and alpha emissions. Actually, it goes along with alpha and beta emissions. Do you understand kung paano yung nuclear reaction natin? Did you get it?
Ma'am,
Yes.
yung sa beta decay, ma'am, yung N, ma'am, ayun na po yung ano, ma'am, yung kinalabasan po nung ano.
Nitrogen.
Nung,
Naging nitrogen siya.
kaya nga, ma'am, ayun po yung kinalabasan na nung
Yes,
sintas,
yes,
no?
yes. Di ba nitrogen is has an atomic number of 7 and atomic mass of 14?
Yes, ma'am.
Okay? So 7, but it takes years bago siya makapag ang half-life kasi ng carbon is 1,000 years bago siya mag-decay.
Pag beta, ma'am, di ba, pa-plus po yung ano, yung nasa taas po ma'am, tapos minus yun sa baba.
Of course,
Sa-
that's negative siya.
Ganon din po sa ano, ma'am, sa alpha, ma'am.
Alpha is positive.
Ano
Alpha
po ulit
is
yan, ma'am, pag
positive.
sa, ano, sa alpha po, ma'am, paano po yung gagawin?
Of course, i-add mo siya plus the transform element para ma-balance yung original. Diba ito, 92 plus 2 is 94. 235 plus 4 is 239. Ito,
Papaligtad po.
anong pabaliktad?
Ito, ma'am, kasi ma'am, di ba yung C, tas ma'am, yung inuuna ma'am sa beta. Tapos ma'am, yung sa alpha naman, ma'am, is yung ano na, UNHE.
I can't understand yung sinabi mong pabaliktad.
Ma'am, di ko rin po maintindihan sinasabi ko, ma'am, eh. Pero naiintindihan ko po, ma'am.
Negative 1 kasi ito. So how do you add sign numbers? How do you add sign numbers? Meaning to say, in beta decay, a neutron is converted to a proton, kaya nag-increase yung proton mo dito, naging 7. Ngayon, nag-emit din siya ng beta particle. Kaya 6 din siya originally. 7 minus 1 is equal to 6. Okay?
Okay, ma'am. Okay, ma'am. Gets.
Now, the types of radiation, we have gamma emission. Pag gamma emission, di ba sabi ko sa inyo, it actually doesn't emit any particle. Gamma ray lang siya, gamma ray, or a form of energy. It is the high energy electromagnetic radiation given off in most nuclear reactions. Gamma rays are not matter. They are energy. That's why they don't have mass. They don't have atomic number. Therefore, they are not involved in balancing the nuclear equation. They are very damaging and difficult to shield against. Okay? Pag may radioactive fallout, ito yung nagpe-penetrate. Dapat makapal ang pang-shield para hindi siya mag-penetrate. Now, there are actually 4 types of nuclear reactions. So the first one that we took up is radioactive decay. That is the emission of the following particles: gamma, alpha, beta. And another one pala is positron. Si positron is the opposite of beta. Pag si beta, negative 1 ang charge. Si positron naman, positive 1 ang charge. Positive 1 ang charge. Kikita niyo mamaya. Another one is nuclear disintegration. Ano ibig sabihin ng nuclear disintegration? That is, you are going to balance the emitted proton or neutron. Ang ibabalance nyo dito naman is just the protons and the neutrons, not considering the decay. Hindi nyo ko consider yung decay dito. Ibabalance nyo lang yung number of protons and neutron. Next is fission, the splitting of the nucleus. Now, the opposite of fission is fusion. Combining of nuclei naman ito. Si fission, isang nucleus, okay, it will be bombarded by a neutron para mag-split siya. Now, pag nag-split si nucleus into 2, and then the 2 nuclei will split into 4, 4 into 8, 8 into 16, etc., etc. That is fission. This is the principle behind nuclear power. Ito yung principle behind nuclear power in the form of electricity. Sa fusion naman, this is combining of nuclei. One nucleus plus one nucleus will form a nuclei, and so forth and so on. Okay? Ibig sabihin, mag-fuse kasi nga fusion ang mga nuclei para makapag-form ng another element or another isotope. Now, this is now a representation of how the reaction is in gamma emission. Generally, companies add the radioactive radiation because it is the energy lost from settling within the nucleus after a change. So dito, okay, uranium-92-238 will decay according to alpha plus gamma. Okay, ito si gamma. So the product or the transform element is 90-234 thorium plus alpha decay or alpha particle 2 helium-4 plus 2 gamma. Yung 2 dito, it's just a representation of the gamma ray. Pero pag minultiply mo ito, 2 times 0, 0 pa rin. 2 times 0, 0 pa rin siya. So it doesn't do anything with the balance equation. So, ang gagawin nyo lang ay ibabalance nyo yung protons, I mean to say yung atomic number, 90 plus 2, or 9 is equal to 92, and 234 plus 4 equals 238. This is now what we call gamma emission. Ipapakita mo dito na mayroong gamma, which was emitted. Now, this is what alpha emission does in order to attain stability. Happens when the atomic number is greater than 83. So nakita nyo naman 92, di ba? 92 yung atomic number natin. So, greater than 83. The 2 protons plus 2 neutrons, that is, that 2 helium-4 loss, brings the atom down and to the left toward the belt of the stable nuclei. So, this is what happens during alpha particle emission. Itutulak niya yung line papunta dito sa stable nuclei, going to the left, downward. Going to the left, downward. Ito si helium, helium-24. Okay? Going to the left, downward to attain stability. Now, this is now alpha particle emission. So, hindi na naka-indicate dito si gamma. So, for this, uranium-238 shall be transformed into thorium-234. Paki-ano nyo to it should be 234. Ito hindi 238. Dito yung naka-red. It should be 234 plus alpha particle 2 helium-4. So this is now the balanced equation, balanced nuclear equation. 234 plus 4 is 238, 90 plus 2 is 92. Now for a beta emission, a beta particle, which is a high energy electron, of course the charge is -1, is emitted from the nucleus as a neutron is converted into a proton. Take note, a neutron is converted into a proton. As you can see here, di ba? Nag-increase ng 1 si xenon. Pero nag-emit ng beta particle, -1 E0 or -1 beta 0, pwede rin. So in here, the balanced equation shall be 53 iodine 131 will be transformed into 54 xenon 131 plus a beta particle. If you add 54 minus 1 is equal to 53. 131 plus 0 is 131. Pati dito sa carbon. Kanina, example na natin ito, di ba? 6 carbon 14 will be transformed into 7 nitrogen 14 plus a beta particle, -1 electron 0 or -1 beta 0. Got it? Do you understand? Ha? Naintindihan nyo?
Yes po, ma'am.
Sinsay? Miss Sinsay? Naintindihan? Miss Sinsay? Naintindihan mo, Miss Sinsay? Hello? Anyan pa ba si Miss Sinsay? Miss Sinsay, please respond or else you will be marked absent. Miss Sinsay? Okay. There are some markings already in your attendance pag hindi kayo nagre-respond. Now, what does the beta particle do? Okay. This happens to a nuclei with high neutron to proton ratio. Diba mataas yung neutron kanina 238. A neutron becomes a proton also, causing a shift down and to the right on the stability graph. So the tendency for the beta emission in order to attain stable nuclei is to push stability line to attain what we call stable configuration downwards to the right. Downwards to the right naman siya. Para ma-reach niya this point, itong point na to. Kasi mas maraming neutrons 248. Masyadong mataas. So the tendency for it dito sa taas na siya. Now, another is positron emission. Now, a positron is an antimatter. Antimatter siya. It is an antimatter particle that has the same mass as an electron but has a positive charge. So, opposite siya ni electron. A positron is emitted from the nucleus as a proton is converted to a neutron. So actually, this is not the opposite of positron. Actually, class, pwede kong baliktarin yung reaction dito. Krypton 3681 will undergo beta decay and then it will be transformed into 37 rubidium 81. Okay, and then fluorine 918 will be transformed into 8 oxygen 18, pero it emitted positron. Nag-emit siya ng positron. So kabaliktaran naman nito. Pag positron, positive ang charge, positive 1. Pag electron, negative 1 ang charge. Okay? So balance na yung reaction natin. 8 plus 1 is equal to 9. 18 plus 0 is equal to 18. Ito naman yung tinatawag na positron emission. So what does the positron emission do? It happens to a nuclei with a low, mababa naman yung neutron. Low neutron to proton ratio. A proton becomes a neutron, causing a shift up and to the left. So meaning to say, itutulak ni positron emitted yung stability line going upwards to the left. Going upwards to the left. Naintindihan nyo? Remember, ito yung limit natin. Ito, up to this point. Now, this graph now shows all the trends of decay and the band of stable nuclei. So, when you combine it, of course, alpha, it attains stability by pushing downward to the left, beta pushing downward to the right, and of course, electron emission or electron capture. Pag capture, nandun siya sa reactant. Pag emission, nasa product siya. Patulak niya pataas to the right. Okay, so this is now how the three emissions do in order to attain stability. Now, this figure shows you how to protect from the penetrating power of radiation. Alpha particle can be shielded by sheet of paper. Beta can be shielded by a thin sheet of copper or thin sheet of aluminum. And for gamma, you can make use of lead, thick piece of lead, or what we can also make use of concrete. Now, this is a summary of what we took up. Para hindi kayo malito. Now, alpha is symbolized by 2 helium-4, beta -1, 0 beta, and gamma 0, 0. So the particles emitted here are helium nucleus, and then high-speed electron for beta, and high-speed photon for gamma. Itong photon na ito, we are referring to the energy that is being emitted when a gamma ray is, when the decay is about gamma. Of course, we can say that the gamma emits alongside with alpha and beta particles. So the mass is decreased by 4 for alpha, no change for beta, no change for gamma. Now, the atomic number decreased by 2, increased by 1 naman si beta, and no change for gamma. What is happening? Helium nucleus is given off. Neutron changes to proton, and of course, gamma accompanies alpha and beta decay. Okay? Before we proceed, are there any questions regarding this? Are there any questions regarding this?
None, ma'am.
Okay. Next. The decay series. So, anong ibig sabihin ng decay series? It is a series of radioactive nuclides produced by successive radioactive decay until a stable nuclide is reached. Ibig sabihin, class, pag yung element na transform into another element, it doesn't mean to say na mag-stop na siya. Pag unstable pa rin yung element na yon, it continues to decay until such time that it attains what you call stability already. So before going to half-life computation and what might remain during decay, let's take first how radiation is detected, especially to those people who are working in nuclear research or working in a nuclear power plant. These are what we call film badges. Ito inilalagay sa arm ng employee, which are used to monitor the amount of radiation exposure people have received. Okay, so as much as possible, pag medyo malapit na doon sa tolerable amount, this gadget monitors how much of radiation is being what you call, or how much radiation already has been exposed to a particular person or people who are working in radiation-laden area. Yes, Mr. Aquino.
Ma'am Marquez, ma'am. Pwede ma'am malaman, ma'am, kung ano po yung kung gaano po kadami yung amount ng radiation, ma'am, yung kayang i-take ng isang tao.
Actually, Mr. Marquez, we don't have any data for that. May kanya-kanya kasing may kanya-kanyang tolerance limit. Okay? Actually, I haven't checked how much.
Okay, ma'am. Thank
So
you.
I'm sorry I cannot answer your question.
Okay lang po.
Okay? There is a certain LD50 that they make use of. Parang yun yung parang pag nagpapa-blood chem ka, di ba? Pag nagpa-blood chem ka, dapat hanggang dito lang. Na pag sumobra doon, you will undergo medication. Similar to that. Yung mga, of course, yung mga nagtatrabaho sa mga X-ray laboratory, hindi naman sila exposed kasi they make sure that they go out as soon as the test is done. Now, another instrument to measure or the one that detects radiation is by the use of Geiger counter. Instrument that detects radiation by measuring current produced by gas particles ionized by radioactivity. Okay. So let's take the uses of nuclear radiation. Since the physical and chemical properties of radioisotopes of an element are the same as stable ones, many uses for radioactive nuclides are possible. So let's consider now as one of the uses in medicine. In medicine, radioactive nuclides are used to destroy cancer cells and as tracers to track substances through the body or identify cancer and other diseases. Ito yung tinatawag na cobalt therapy or radiotherapy that is possible to destroy cancer cells. They make use of what we call cobalt-60. 60 is the atomic mass of cobalt that is being used, or we can call it cobalt therapy. Okay? Now, of course, as radioactive tracer also, di ba, sa mga X-rays, if somebody undergoes an X-ray, makikita if you have an enlarged heart, kung mayroong particular thing that is, halimbawa, nakalunok ka ng coin, makikita sa X-ray. So, ibig sabihin, it is really a radioactive tracer. Like other MRI, mga MRI, what else? in order to detect if there is already something wrong to the different parts of our body or mga organs natin. So they are serve as radioactive tracer also. Now, in agriculture also, radioactive nuclides are used as tracers in fertilizer to determine the effectiveness or to prolong shelf life of food by irradiating to destroy microorganisms. And this is what I'm telling you a while ago. It is also being used for carbon-14 dating. Carbon-14 dating. So carbon-14 is produced at a constant rate in Earth's atmosphere and is in a fixed ratio to carbon-12 in living plants and animals. So not only that we consider carbon-12, mayroon din carbon-14. So the ratio of carbon-14 to carbon-12 in organic material like wood, leather, cloth, antlers decreases by half every 5,730 years. So ito na yung half-life ng carbon-14. So in dating, radioactive nuclides are used to determine the age of objects. For example, carbon-14 is used to date organic materials. Actually, class, there was an instance wherein they were able to determine the age of a mummy, M-U-M-M-Y, na nakapreserve sa isang country na may snow. Doon siya na-preserve sa snow, and they were able to detect the age of that particular mummy by making use of carbon dating. Okay, so 14 carbon, 8 carbon 14, the half-life is 5,730 years. Ibig sabihin, nagdi-disintegrate siya, nagdi-decay siya every 5,730 years. Can you imagine that? Okay? And carbon-14 is a beta emitter. Nag-emit siya ng beta particles. Now, and one of the most important use of nuclear radiation is what we call in energy production, di ba? In energy production, current nuclear fission is used to create energy. So fission ang principle behind. So example, Comanche Peak Nuclear Power Plant in Glen Rose produces energy that is used by TXU energy somewhere abroad. Tayo, dito sa Pilipinas, during the time of President Marcos, he initiated the Bataan Nuclear Power Plant, which was aborted when he was prior to his eviction from office. Diba? Sa history ninyo, na-evict siya from office and he was replaced by President Aquino. Okay? So if you happen to have a field trip, because we had a field trip before in Bataan Nuclear Power Plant, there are areas there that you have to be restricted from going to because it is somewhat risky. It is the particular area may nakalagay na radiation hazard symbol. It means to say never to go near it. So of course, pag mayroong nuclear power plant, mayroon ding nuclear waste. So how do they contain the nuclear waste coming from nuclear power plants and also those undergoing medical research with regards to what you call nuclear research. So nuclear fission produces radioactive waste that must be contained and stored on site temporarily or disposed of permanently. Okay? Hindi pwedeng ikalat-kalat mo lang ang nuclear waste. Remember, they are radioactive. So how do they contain it? Radioactive waste from medical research has half-lives of only a few months. Okay, so ibig sabihin, this waste attains stability for only a few months. Now, waste in nuclear reactors will take hundreds to thousands of years to decay. Now, of course, because of this, it is best for them to contain. Kailangan maitago or mailigpit or maidispose ang mga nuclear waste na to. So, spent fuel rods from nuclear power plants are stored in either water pools or dry casks. This is temporary, and at some point, the rods must be removed to underground storage facilities. There are what we call number of storage facilities in the US, 77 disposal sites in the US. Disposal sites are created with the intention of never going back for the spent fuel rods. Okay, parang hindi na muling magamit or hindi maikalat. Now, the current storage permanent disposal site is WIPP near Carlsbad, New Mexico. This is somewhere in Mexico, near the city of Carlsbad. Okay, so this is the storage site, disposal site. As you can see, it is far away from the habitat of people, no? Malayo sa kabihasnan, kumbaga. So, of course, this is being manned by people which are actually, of course, they have the necessary protection from radiation. Okay? Okay, so another reaction is what you call the nuclear fission. Yun yung pagdi-divide ng nuclei. So, a neutron is bombarded into a nucleus. So, binombard mo ng neutron, si uranium-235. So, pag binombard mo siya ng neutron, mag-i-increase yung atomic mass niya. So, it became uranium-236, which is an unstable nucleus. So, the tendency for this is to decay into fission. Okay? Ibig sabihin, magdi-divide yung nuclei. Magdi-divide yung nuclei in order for it to be formed into such elements like, for example, we have krypton-92 or barium-141. But a large amount of energy will be spent. We have 2 times 10 to the second power kilojoule per mole. Okay? Parang ganito, it is represented by the splitting of nucleus. So let us define what is nuclear fission first. Fission is the splitting of atoms. They are usually very large so that they are not stable. A chain reaction begins wherein the material that starts the reaction is also one of the products of the reaction and can start another reaction. So it is represented by this. Okay? A neutron is bombarded to a nucleus. A nucleus has been bombarded by a neutron, in which case it will be splitted into 2 nuclei. The 2 into 4, 4 into 8, 8 into 16, 16 is to 32. Ito yung fission process na tinatawag, which is the principle behind nuclear power. Okay, so nuclear fission and power. Currently, there are about 103 nuclear power plants in the United States and about 435 worldwide. Now, 17% of the world's energy comes from nuclear power in the form of electricity, of course. So this is now the percent of electricity produced using nuclear power plant per country. So in France, you have 75% produced, Lithuania 72.1, Belgium, etc., followed by Bulgaria, Slovak Republic, and Sweden. Now, United States is number 19, followed by Russia and Canada. Okay, so marami nang gumagamit. So they are not what you call, like, unlike us in the Philippines, nagkakaroon tayo ng brownouts kasi minsan na kulang ng power, no? Kulang supply ng electricity. Okay, so this is now nuclear fusion, which is the opposite of fission. So when you say fusion, small nuclei combine. So let's say, for instance, hydrogen 2 plus hydrogen 3 will give you 4 helium plus 1 neutron plus large amount of energy. Now, helium-2, of course, is non-radioactive. Helium-3 now becomes radioactive. Okay, so you will be producing 2,4-helium. Now, actually, this reaction, fusion reaction, occurs in the sun and other stars. Take note, a very large amount of energy. And of course, this is the principle behind hydrogen bombs, yung fusion. Oops, half-life. Now, excessive heat cannot be contained with regards to fusion reaction. Uncontrolled fusion reactions of hydrogen are the source of hydrogen bombs. Their attempts of a cold fusion have failed, never a success. Hot fusion is difficult to contain actually. Okay, so that is now the difference between fusion and fission. Are there no questions? So let's go now to half-life. Magko-compute na tayo ha. Be ready with your periodic table, calculator, and scratch papers. Ito yung magiging seatwork natin. Next meeting na lang siguro on Saturday. Kukulangin na tayo sa oras. Okay, what do we mean by half-life? Half-life is the time required for half of the atoms of a radioisotope to emit radiation and to decay to products. Okay, ito yung time na kailangan. Okay. When radioactive isotopes decay, they do so exponentially. The rate of decay is determined through an understanding of half-life. It is the amount of time it takes for half of the atoms of an unstable isotope to decay. Atoms with short half-lives are more unstable than those with long half-lives. Halimbawa, those elements that are being produced in the laboratory, yung radioactive elements being produced in the laboratory, sometimes seconds lang nagdidecay na sila. But they are considered to be more unstable than the ones with long half-lives. Okay, so like for example, the decay of 20 milligrams of oxygen-15, what remains after 3 half-lives? What remains after 5 half-lives? Okay, so you start with 0. This is time in minutes versus the mass in grams or milligrams or in terms of atoms. So after a certain half-life, after the first half-life, magdi-decrease na yung amount ng element, and then followed by a second half-life, the more it will decrease, followed by the third half-life, the more that it will decrease. So hahanapin nyo ngayon how much will remain after a certain series of half-lives. So ito na yung kinetics of radioactive decay. So paano gagawin nyo to determine how much is remaining? So for each duration of half-life, 1/2 of a substance, 1/2 of the substance decomposes. Nagdi-decompose siya. For example, we have radium-234 has a half-life of 3.6 days. If you start with 50 grams, how much will remain after 10.8 days? Okay, so ganito yung gagawin nyo. You start with 0. Okay, 50 grams, 0 days muna. Tapos, nag-half-life siya ng 3.6 days. So, anong naiwan? Kalahati na lang, 25 grams. Kasi nga half-life. Ngayon, after another series of half-life, so ang gagawin nyo, idadagdag nyo ulit yung 3.6 days. So, add 3.6 days again, magiging 7.2 days. Then, i-half nyo ulit yung 25 grams, magiging 12.5 grams na siya. Then, after the next series of half-life, i-add nyo ulit yung 3.6 dito sa 7.2. So, it becomes 10.8 days already. And you have to divide this by 2 again. 12.5 divided by 2, 6.25 grams. Ang naiwan na lang after 3 half-lives is 6.25 grams of radium-234. Okay? Got it? Naintindihan niyo kung paano? Class? Naintindihan niyo ba kung paano kunin ang half-life and mass remaining? Sumagot naman kayo, oh. Hello, naintindihan niyo ba? Mr. Estribor, naintindihan mo? Mr. Estribor? Nandiyan pa ba kayo? Hello? Naintindihan? O, naintindihan mo ba, Mr. Romano? Shall I show you how it is done? Papakita ko ba? Ha? Okay, ito next example na lang. Okay. The half-life of iodine 123 is 13 hours. How much of a 64 milligram sample of iodine 123 is left after 39 hours? How much is left after 39 hours? Huh? Okay, sige, papakita ko sa inyo. So, ano ba yung problem? 39 hours, tapos 64 milligrams. 13 hours ang half-life. Wait lang ha. Actually, may klase na ako at 1:30. Tapusin lang natin ito. Okay. Ano yung half-life kanina? 13, ano? 13 yung half-life.
13 hours, ma'am.
Okay, so we start with ilang grams? 64, no?
64, ma'am.
64 grams. Okay, start muna kayo sa 0 kasi hindi pa siya nagde-decompose or nagde-decay. Zero ano pa? Hours ba yun or days? Sa problem. Hours ano? Hours? Okay. Now, pag nag-start ng mag-decay, hahatiin natin to. So, 32 grams na lang siya. Nag-decay na siya ng 13 hours. So, after 13 hours, ito na lang ang naiwan. 32 grams. Okay, got it? Now, hatiin natin ulit ito kasi di ba nga half-life? 632 divided by 2 is 16 grams. So what you're going to do is add another 13 hours or you can multiply it by 2. Second series, multiply it by 2. Third series, multiply it by 3. Or pag nalilito kayo, pwede namang add-add na lang gagawin nyo kung ayaw mag-multiply. So we have now 26 hours. Diba? Anong tanong? After 39 hours, how much is left? Diba? Tama ba? So after 39 hours, so 26 plus 13 is 39 hours, diba? How much remain? I-divide nyo ulit ito by 2. So 8 grams na lang ang naiwan. So ang sagot nyo, 8 grams. O, naintindihan?
Yes po. Yes po.
Ganyan lang kasimple ang calculations. Pero pag nakamit kayo ng problem regarding this, you have to understand the problem properly para alam nyo kung paano gagawin nyo. Ha? Now, the half-life here is in terms of hours. Hours lang. In some problems, it takes years. Yung iba nga, times 10 to the 9 years ang half-life. Pwede din namang every decade, 10 years. Ito sa atin, we took up 13 hours. So idagdag yun lang na idagdag. Even it is in terms of decades or years, idagdag nyo lang. Doble-doblehin nyo, 13 plus 13, 26, 26 plus 13, 39, 39 plus 13, 52, hatiin nyo ulit to, 4 grams na lang siya. Got it?
Yes po. Yes, ma'am.
Okay, you take a screenshot na lang para para mayroon kayong Okay? Sige. Continue natin ito next meeting. Kuha na yung yung simulation